So this is question 4 from the June 2018 Further Pure Maths 2 paper for Edexcel. So for this question, we have a matrix given here as A, which is 1, 1, minus 2, and 4. And we have to find a matrix P and a diagonal matrix D such that D is equal to P inverse times A times P. Now it's 7 marks, so quite a lot of marks. So let's have a go at tackling this. So question 4. So the first thing you ever have to do with a question like this, where you find in diagonal matrices, and you have to find another matrix P, you have to find the characteristic equation. Now, because this is a 2 by 2 matrix, it's quite nice. So what we need to remember is we need to work out the determinant of A minus lambda I. So my matrix that I'm going to work out the determinant of is going to be 1 minus lambda. 1 minus lambda in that top left element. It's just going to be a 1 there. It's going to be a minus 2 there. And it's going to be 4 minus the lambda again. And now I need to work out the determinant of that. So what's that going to give me? Well, that's going to give me 1 minus lambda times 4 minus lambda. So 1 minus lambda times 4 minus lambda. And then we have to do minus 1 times minus 2. So minus 1 times minus 2, so minus minus 2. So I'm going to add 2 to that. And this is equal to 0. Simplifying this, that's going to give me 4 minus 5 lambda plus lambda squared. That's lambda minus plus 2, sorry. So that's minus minus. That's equal to 0. So this simplifies to lambda squared minus 5 lambda and plus 6 equals 0. So this is my characteristic equation here, this quadratic. So how do we work out the eigenvalues? Well, we need to factorize this. So because it's just a quadratic, it's going to be 2 brackets. So I'm going to get one value, and I'm going to get another value. It's going to be equal to 0. So hopefully this is nice and straightforward. It's just from GCSE maths, you just factorise in the quadratic. So that's going to give me minus 3 and minus 2 to give me the quadratic here. So we know, therefore, that lambda 1 is equal to 2 and lambda 3 lambda 2 is going to be equal to 3. So we have our two eigenvalues here. We have lambda 1 is 2, lambda 2 is 3. So we now need to work out the eigenvectors to go along with this. So how do we work out the eigenvectors? Well, we've got to put these values back into this equation here, this matrix here, sorry. So when lambda's 2, I'm going to get 1 minus 2. So I'm going to get minus 1 for that bit there, for that element there. I'm going to get 1 still in this upper right element. I'm going to get minus 2 again here. So this is for lambda 1 equals 2. So this is this bit here. I'm going to get minus 2, and then in this bottom right, I'm going to get 2. Because 4 minus 2 gives me 2. Well, what do I get when I times by xy? When we times this by the matrix xy, we should get 0, 0. 0, 0, like that. Well, what that's going to be is minus x plus y. So minus x plus y is equal to 0. Well, that means, therefore, that x is equal to y. Well, if y is 1, x is clearly 1. So an eigenvector, when lambda 1 is 2, could be 1, 1, for example, like that. So that's my first one. So that's for lambda 1. And then for lambda 2, so we need the 3 value here. We need to put it back in. So 1 minus 3 is going to give me minus 2. So let's just do this one over here. So this is lambda 2. So 1 minus 3, so I'm going to get minus 2. Minus 2 there. I'm going to get 1 here, minus 2 here. I'm going to get a 1 here again. So that's going to be 1, 1, and then minus 2. Times by xy again. And that's going to be equal to 0, 0. Well, what are my eigenvalues here? I'm going to get minus 2x plus y is equal to 0. So therefore 2x is equal to y. So if I picked y is, you know, what I could say that x is equal to a half of y. So x is equal to a half of y, or y over 2. So for example, if I pick y is 2, that's a y. So if y is 2, x is half of that, so x will be 1. So an eigenvector would be 1, 2. That's all 1. So that's for lambda 2. We're nearly there now. For this point here now, getting you 2 eigenvectors, you've got 5 of the 7 marks, so that's quite a lot. For just working out your characteristic equation, working out your eigenvalues, and then working out your eigenvectors, that gets you 5 of the 7. To finish this question now, we need to work out the matrix P. So remember, the matrix P, and do this for all these questions, P is equal to the eigenvalues put into a matrix. So what this is would be a 2 by 2 matrix again with these eigenvectors, sorry. So that's going to be 1, 1 there, and it's going to be 1, 2 here, like that. So that's my matrix P. Well, we need D. We're trying to find the matrix D as well. Well, D is equal to P inverse, so the inverse of this, times A, which is this, times this again. Now, for this last mark, they don't expect you to work out P inverse. At this point, if you're doing further maths, you should have a graphical calculator, so just plug it into there. But what you will obtain is that D is equal to another 2 by 2 matrix. D is equal to 2, 0, 0, and 3. And that's it, guys. You've got your matrix P, you've got your matrix D. So there's quite a lot of working going on, but hopefully it's okay. So that's all 7 marks done for you.